Hi guys, welcome to tutorial 5, question 1. Let's do this. Now I'm going to put the question right down here, pause the video, read it through, attempt it yourself, and then we'll go through it together. Now, as mentioned by over here, when you read over the code, you see that there's a case missing, which is when I equals to length of a minus 1. But I guess the coder or whoever wrote this, obviously us, whoever wrote this basically doesn't want anything to happen. So there is a low-key base case in here. It's just that because it does nothing, we didn't write it. We're going to say let t of n be the worst case runtime of this function, right? And we're going to let where n equals to length of a minus I. Why is that going to be the case? Well, think about it. I is the iterative thing that keeps going through this list A, right? And it keeps getting bigger and bigger. If we're gonna say what's the worst case running time, right? That means it has to go through every single one. So the length of A, all of it, minus I, wherever it is, because we're saying it's the worst case scenario, we want to cover all of it. We're gonna say, all right, length of A minus I equals to n. That's what we're gonna allow to be n. Now, there's two cases. We're going to start with the number one. The number one case is going to be if n is smaller than or equal to 1. What is that? What does that mean? Well, if we rearrange it a little bit, and I'm going to put it right over here, we know that length of a minus I is our n, right? So that's going to be smaller than or equal to 1. Or if we switch the I and the 1 with each other, it's going to be length of a minus 1 is smaller than or equal to I. Now, that means that kind of, it's not that it contradicts, but it kind of does. If I is bigger than or equal to length of a minus 1, if you look at our code in line number 6, right, that means it's never going to go into that if statement, right? So that's what the case n smaller than or equal to 1 means. And because we have to do it in terms of n, that's what we're doing. So, but yeah, in this case, it's not going to go into the if statement and the function is going to end. So, it does, constant amount of work. It goes into a function, does, reads over line number 6, the if statement. It fails it, obviously. And then that's it. It's done. And that's the first case for this in terms of n. Now, what if n is bigger than 1? Well, similar to the last case that we said for n, in this case, we're going to have to check if the first if condition passes or not. So that's some, let's say it's k steps to do that. And then, we finally go in there and, we go into our for loop, right? But, the question arises, how many times does the for loop run? Well, from the for loop, we can see that the range goes from I plus 1 to length of a, right? So we know that it's going to run n minus 1 times. So there's n minus 1 times that the for loop runs plus the number of steps that are in it. So you got to say n minus 1 times some other constant. Let's not reuse k or c. Say d, right? It runs d times n minus 1 times for that for loop. And we can see that after all the for loops, right? If you go at line number 16, you see that it does a recursive call on some case that's smaller. Now, by how much? It says I plus 1. That means they've increased I by 1. Or in other words, they have decreased n by 1, right? It runs 1 less time. So we can see that if n is bigger than 1, or let's say if n is bigger than or equal to 2, we can say that it's going to run k times for the if statement and all, plus d times n minus 1 for the for loop, and then t of n minus 1 times for the line 16 for the recursive call. And, this is our worst case running time for rec SS. And that's pretty much for this question. All right, guys, that will be all for this question. I'll see you guys in the next video. Ugh, can't even talk.